Hey physics fans, today we're going to discuss the concept of double slit interference. Double slit interference occurs when light is directed through two narrow slits. When that occurs, the light diffracts. That diffraction causes a combination of constructive and destructive interference to occur. We've seen this in our discussion of sound. What that does is it creates a pattern of bright and dark fringes that alternate between one another on a screen that opposes the two slits. What a great place is to start with our discussion about double slit interference is a review of the superposition principle. This principle tells us that when I have two waves interacting with one another in space, their resultant is the algebraic sum of each individual disturbance. Let's consider an example to better understand what this means. If I look at my plot here, I have two waves plotted with respect to time. Wave 1 and wave 2. You'll notice that the amplitude of these two waves is the same. However, the peak of wave 1 corresponds to the trough of wave 2. So when I take the algebraic sum of the two, I get 0, as both waves transverse with respect to time. Now, the connection that we need to make between the superposition principle and interference is this concept of path length difference. If I consider these two waves, I want to compare them with a common point. In this case, I'm going to choose the troughs. If I consider my path length for wave 2 here, and compare that to the path length of wave 1 with the same common starting point for each, which is the trough of each, I'll find that there is a path length difference of lambda over 2 between the two waves. Now this is important because having a path length difference of lambda over 2, or having some half multiple of the wavelength, is an indicator that I have destructive interference. Let's look at another case, completely constructive interference. You'll notice here that I have wave 1 and wave 2 propagating with respect to time. You'll notice that the amplitudes are no longer the same between wave 1 and wave 2, but unlike our previous example, here the peaks and troughs between the two waves line up with one another. What this means is that when I take the algebraic sum and apply the superposition principle, the resultant wave is larger in amplitude than each individual wave that is propagating through space. I am adding the amplitudes of both waves at any given point, and I have a larger amplitude there. You should also notice that the path length difference between the two waves is 0. This is important to recognize because it is a key indicator of constructive interference. I can tell that the path length difference is 0 because the peaks and troughs of each wave line up with one another. Now, let's take what we understand about superposition and apply that to double slit interference. Here I have a diagram of what you'll typically see for a double slit problem in this course. I have incident light moving in this direction. It is going to pass through two narrow slits, and that light is going to diffract. That diffraction is going to cause the two light waves to interact. What I care about in our double slit problems is what is the pattern on a screen that on the opposite side from the double slits. Typically, I'm looking at what is happening at any given point P. Typically, we're looking for dark or bright fringes, or destructive or constructive interference. What double slit interference is, it is applying the concept of superposition at a specific point P, and understanding and being able to tell whether or not I'm experiencing constructive or destructive interference. I have two equations that I can use to better understand that. The first one is written here. You'll notice that this term here is looking for integer multiples of wavelength. That is an indication that I'm looking for constructive interference. Alternately, if I consider this term here, I'm looking for half multiples of wavelength. This is an indication of destructive interference. And we saw that with our first example. When I have a half multiple of wavelength, I have two waves that are experiencing destructive interference, and I would see that in the form of a dark fringe. Well, conversely, if I have two waves that are an integer multiple of wavelength from one another, that would be constructive interference or a bright fringe. even though in this particular example we considered two waves that started from the same point, if I was an integer multiple of wavelength out of phase, I would start, say, my second wave here, and my waves would still be in phase with one another, and they would algebraically add with one another. That concludes our discussion on double slit interference today. Do not hesitate to ask your instructor if you have any questions in class.